Welcome to the DIY Honda Garage channel. This presentation addresses the Diagnostic Trouble Code P0087, which indicates that the fuel rail pressure is too low in the 2017 to 2022 Honda CRV models. Proper fuel pressure is critical for the engine's fuel injection system, influencing engine performance and efficiency. The fuel rail is a component where fuel is stored temporarily before being injected into the engine cylinders. It is connected to the fuel tank and fuel pump, making it essential in maintaining adequate pressure for fuel delivery. If the system does not operate within the required thresholds, it can lead to various issues, prompting the need for thorough diagnostics. This guide will explain the symptoms and causes of P0087, as well as step-by-step troubleshooting instructions to identify and resolve this issue effectively. The DTC P0087 specifically refers to a situation where the fuel rail pressure falls below acceptable limits. The fuel rail itself acts as a conduit for fuel from the high-pressure fuel pump to the engine fuel injectors. If the pressure is too low, the engine may not receive sufficient fuel, leading to suboptimal performance. The fuel rail pressure sensor continuously monitors the pressure and reports any discrepancies back to the Powertrain Control Module, PCM. This sensor is typically situated close to the fuel rail. If this sensor malfunctions or records a low-pressure condition, it will trigger DTC P0087 to alert the driver or technician to the problem. Understanding the key components involved is fundamental in troubleshooting this code. Several potential causes can trigger the P0087 code, and identifying the root cause is essential for effective repair. First, a fuel leak anywhere in the system can lead to pressure losses that will trigger this code. It's crucial to repair any leaks before proceeding with diagnostics. Additionally, a weak or failing fuel pump may not generate enough pressure, leading to low readings. Blockages in fuel lines, such as dirt or debris, can also significantly reduce pressure, causing issues. Lastly, a faulty fuel rail pressure sensor may provide misleading data, causing the PCM to throw this code despite normal operating conditions. Therefore, each of these elements should be examined during the troubleshooting process. The symptoms associated with DTC P0087 can vary, but are generally related to fuel delivery issues. Drivers may experience engine stalling or misfiring, especially under acceleration or load conditions, leading to a jerking sensation when driving. Poor acceleration is also a common sign, as the engine struggles to receive adequate fuel. Another noticeable symptom is difficulty in starting the engine, as insufficient fuel pressure can impede the initial combustion process. Additionally, the check engine light will illuminate on the dashboard, alerting the driver to the presence of a malfunction. Recognizing these symptoms can help pinpoint the problem early and initiate the necessary repairs to restore proper vehicle function. The first step in troubleshooting DTC P0087 involves problem verification at idle speeds. Begin by turning the vehicle to the on mode without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear the Diagnostic Trouble Code, which resets the system and prevents old data from causing confusion. Once the DTC is cleared, start the engine and maintain a steady speed of 3,000 RPM without any load, either in park or neutral, until the radiator fan activates. This step ensures that the engine is operating under controlled conditions, allowing for accurate assessment. After this, you will perform the DI fuel pressure test using the HDS, which will provide critical data regarding fuel pressure and whether the results are acceptable. Depending on the outcome, you will decide on subsequent steps. In Step 2 of troubleshooting, you will perform a test drive of the vehicle to gather dynamic data related to fuel pressure. It is essential to monitor various parameters, including engine speed, vehicle speed, and signals from sensors like the manifold absolute pressure (MAP) sensor and throttle position (TP) sensor. While driving, pay close attention to the fuel pressure converted from PF sensor and the direct injection system readings. After a few minutes of driving, return to the HDS to check for any pending or confirmed DTCs, particularly P0087. If P0087 appears again, it indicates that the issue persists and will warrant further investigation. If no DTCs show up, it may suggest an intermittent failure, prompting a check of the Powertrain Control Module, PCM, and related components. Step 3 involves assessing the operation of the spill valve associated with the high-pressure fuel pump. Start the engine and allow it to idle, paying close attention to any noises or vibrations that may emanate from the spill valve. This valve is designed to manage excess fuel pressure, and any irregularities could signal a problem with the high-pressure fuel pump. If you do perceive noise or vibration, it generally indicates that the spill valve is functioning as intended, allowing you to progress further in your troubleshooting. However, if no sound is detected, it suggests that the high-pressure fuel pump may need to be replaced. This step is pivotal because it directly links the functionality of the fuel system components and leads you closer to identifying the issue causing the low fuel pressure. In Step 4, you will perform a comprehensive check of the fuel rail pressure sensor's performance. To start, turn the vehicle off and remove the PGM-FI main relay 2, a crucial component that controls fuel injection functions. Once the relay is removed, you will start the engine and let it idle until it eventually stalls. After stalling, crank the engine a few times to gather data. Using the HDS, you will check the fuel pressure parameters. Focusing on the values converted from the PF sensor, you should expect readings of less than 1000 kPa, and it is acceptable if the values are in the several hundred kPa range. If the current conditions match this threshold, you proceed to the next step. If not, it usually means that the fuel rail pressure sensor needs replacing. Accurate measurement is essential to understand the actual performance of the fuel system. Step 5 involves a repeat check of the fuel rail pressure sensor under operational conditions. Start by turning off the vehicle again and reinstalling the PGM-FI main relay, ensuring that the fuel system is back in its normal state. Once the relay is in place, start the engine and hold it at 3000 RPM without any load until the radiator fan comes on. Then allow it to idle, shifting the transmission into drive while firmly pressing the brake and accelerating brings additional dynamics into the system. Using the HDS, you will again check the fuel pressure converted from the PF sensor and the direct injection system. Ideally, both values should be nearly identical. If they are consistent, you can move on to the next troubleshooting steps. If not, it indicates a fault in the fuel rail or its pressure sensor, requiring further intervention. In Step 6, the focus shifts to assessing fuel pressure from the low-pressure side of the system. Checking the overall fuel pressure is essential, as low readings may indicate issues like a weak fuel pump, a faulty fuel pressure regulator, or even a clogged fuel filter. If your readings are within acceptable ranges, you can confidently advance to the next steps. However, if the pressure is non-compliant, each component affecting fuel delivery, including lines and connections, must be investigated thoroughly. Understanding how these components interact ensures a complete approach to diagnosing fuel system issues. This step is vital because it encompasses several critical elements of the fuel supply system, each of which affects performance. Step 7 emphasizes the visual and functional inspection of the high-pressure fuel pump. To do this, you'll first need to remove the high-pressure fuel pump unit from the vehicle. Once removed, conducting a thorough inspection of the cam and roller components is necessary. Look for signs of wear or damage, as these small parts play a significant role in the operation of the pump. If these components appear to be in good condition, you can place the high-pressure fuel pump as a precautionary measure to ensure optimum performance. However, if you detect damage, a decision must be made whether to replace both the intake camshaft and the pump itself. Correcting these issues helps maintain the necessary fuel pressure, crucial for proper engine operation. The final repair verification step is crucial to ensure that all troubleshooting and repair measures have been effectively executed. Start by rechecking all systems, both visually and through diagnostic tools like the HDS. It is important to confirm that no DTCs, including P0087, are present upon the vehicle's restart. This process may require a brief test drive under various conditions to ensure that the vehicle is operating correctly without the recurrence of engine performance issues. Monitoring performance during this stage allows you to validate the effectiveness of your repairs thoroughly. This verification not only ensures that the problems have been addressed, but also provides peace of mind for both the technician and vehicle owner, confirming the success of the service. In conclusion, DTC P0087 signifies a critical issue of low fuel rail pressure, which can significantly affect engine performance in the Honda CRV models from 2017 to 2022. Understanding the roles and functions of key components, such as the fuel rail, fuel pump, and pressure sensors, is essential for effective troubleshooting. This guide has outlined systematic steps to diagnose and resolve the underlying issues, including checking for leaks, verifying the operation of various components, and using diagnostic tools effectively. Remember that each symptom may guide you to possible causes, and addressing multiple DTCs if present can lead to a more successful repair. Proper verification and testing after repairs will ensure the vehicle is returned to optimal operating conditions. Each of these measures is crucial not only for solving immediate problems, but also for maintaining the long-term health of the vehicle. Please like and subscribe to the channel. See you next time!